Hello everyone and welcome to lecture 2 of Iupac Nomenclature. So far we have seen the basic format of Iupac Nomenclature and we have discussed each of these part in detail in our previous class. Today we are going to pick up the single most important step in Iupac Nomenclature, and that is going to be selecting the parent carbon chain. Before we start, we need to make ourselves familiar with the priority order that we are going to follow when selecting the parent carbon chain. As per the priority order, we must give first priority to the primary functional group. What are the different functional groups? We have already discussed them in our previous class. For example, carboxylic acids, sulfonic acids, then esters, then acid halides, then amides, nitriles, and so on. Now this is the priority order. For example, if your given carbon compound has a carboxylic acid as well as alcohol in it, then the primary functional group would be carboxylic acid. If the compound has a ketone as well as alcohol functional group, the primary functional group would be ketone. Likewise, if the compound has alcohol as well as amines in it, then our primary functional group would be alcohol. Okay, so let us take one example. So let us have this carbon compound. This particular carbon compound has only one functional group, and our first job is to identify it, COOH. This is our functional group called as carboxylic acid. But if say I had another functional group attached somewhere over here, say OH, then we had to decide which is our primary functional group. Is it COOH or OH? In that case, we will refer to the priority order of functional groups which is given. We will say, as per the priority order, COOH should be my primary functional group. The moment you have selected the primary functional group, the other functional group becomes your substituent. This becomes your substituent. And this guy, your primary functional group. So whenever a compound is given, your first job is to see to it that if a functional group is present, then it must be selected in PCC. You cannot leave it out. You cannot leave this carbon of COOH out of your PCC. You must include it in your parent carbon chain. The second is the multiple bond. Multiple bond would be our double bond or a triple bond. All right. So, for example, let me extend this one and put here C double bond C. You have to make sure that the selected parent carbon chain has as many double or triple bonds as possible. At this point, we do not distinguish between double or triple bond. For us, simply it is a multiple bond. For example, in this particular compound, this guy is our primary functional group, so it must be included in PCC. This is our substituent. So when selecting the parent carbon chain, we will select like this. We will include this carbon. Then we will move here. Now at this carbon, we have to make a decision whether to go straight or whether to go down. In that case, we will refer to our priority list. We will say, after functional group, after this guy has already been included in PCC, my job is to see to it that I have multiple bonds, as many as possible. So if I go straight, I miss out on this double bond. So I cannot move straight. Now you will have a doubt. Sir, but OH here functional group is there. No, this is no more a functional group. The moment you have selected COOH as per the priority list, at the moment we have selected COOH as our primary functional group, automatically all other functional groups become our substituent. So this OH is like any other substituent like methyl, ethyl, ethoxy, methoxy, fluoro, chloro, so on. So OH has become our substituent now. So you don't go like this because you want to select OH. No, that's not correct. We will from here come down and our parent carbon chain would become this one. Let us move ahead and see some examples. In example 1, there is a functional group. Which one is that, sir? Sir, it is a COOH carboxylic acid. And therefore, we must include carboxylic acid in our PCC. In example 2, I have two functional groups. One is COOH and other one is OH. Now we have to decide which is going to be our primary functional group or the principal characteristic group, and that is going to be our COOH. COOH has the highest priority among functional groups. If COOH is there, carboxylic acid is there, that becomes our principal or the primary functional group. Now, when selecting the PCC, the priority is given to the primary functional group, which means that when selecting the PCC, this carbon must be included in the chain. Now, there are two ways that I can select the PCC. I can go straight or I can come down over here. So, once I have selected this part, over here I will ask myself a question. If I go straight, then I get 2 carbons. If I move down, then I encounter only 1 carbon. So after functional group, my priority would be to include a multiple bond. But in the given compound, there is no multiple bond. So in this particular case, I'm going to ignore this criteria, this priority, because it's not there only. I'm going to move to the next criteria, that is number of carbons. I have to choose that path in which I will find maximum number of carbons. If I go straight, I encounter 2 carbons. If I move down, I encounter only 1 carbon. So in that case, I will go straight. So this one would become our parent carbon chain. Let us move to the second example. Sir, I have two functional groups, COOH and OH. Already told you that COOH is your primary functional group. The moment you decided this is your primary functional group, this guy becomes your substituent. This guy becomes your substituent. All right. Now, that means I have to include this carbon. That is, from this end, I could go straight, or from this end, I could come down. So at this carbon, I'll ask myself one question, whether to move straight, whether to go down. Since there are no multiple bonds, I'll move to the next criteria of selecting more number of carbons, and therefore I will go straight. So I hope you understood that. Let us move to example number 3. Over here. Is there a functional group? Is there a functional group? Yes, sir. How many are there? 2 are there. One is OH, one is COOH. Carboxylic acid and alcohol. In that case, we need to decide whether carboxylic acid or OH is our primary functional group. Already told you COOH, carboxylic acid, is your primary functional group. Okay, which means that this carbon must be included when selecting the PCC. So that means we will start from here, move to this carbon. Now we have moved to this carbon. I ask myself one question, whether to move straight or go down. So I check the criteria. On moving straight, do I get the primary functional group or something? No. Are there any multiple bonds straight? No. But is there a multiple bond down? Yes. So before going ahead, I'll ask myself a question. Is there a multiple bond? There is no multiple bond over here, but there is a multiple bond down over here. So I will select this one. So once we have selected the primary functional group, it is I have to see to it that I include maximum multiple bonds, as many as possible. If I had to go straight, I would miss on this double bond. And as per the priority list, I have to prioritize multiple bonds over number of carbons. First, you have to check, is there a multiple bond? Yes, then you should go over here. Achha. What if there were multiple bonds over here also? Let me say that there was a multiple bond over here. In this case, how would we select a parent carbon chain? We would say, sir, this is my primary functional group and hence it must be included in PCC. So my PCC would look like this up till here. Now here comes a question. Whether to move straight, whether to go down. Sir, if I go straight also there is a multiple bond and there is precisely one. And if I go down, then also there is one double bond. There is one multiple bond. So go straight, go down. Either ways, you have a multiple bond. You are not missing on multiple bond. Therefore, at this level, the conflict cannot be resolved. You cannot decide based on multiple bonds whether to move straight or to go down, because both paths have a double bond or both paths have a multiple bond. So at this point, you say, since multiple bond cannot resolve my conflict, I shall then go to the next part, that is number of carbons. Now you ask yourself, in which direction if I go, I'll get maximum number of carbons? Well, if you go straight, you have 2 carbons. If you move down, you have only 1 carbon. That means we will move straight away. The point that I'm trying to make is that you have to try to resolve the conflict at the first level. Only if it is not possible to resolve the conflict will you check the next criteria. Similarly, once you have moved to the next criteria, at this point you should try to resolve the conflict. If not, then only you move to the next priority. Let us move to the next example. Well, next example is quite simple. I have COOH as my functional group, but it is present twice. If a particular functional group, if the same identical functional group is present 2 times, then both of them must be included. The point to be noted is that this is your primary functional group. Likewise, this is also your primary functional group, because they are same, they are identical. They are not like example 3. You had a carboxylic acid and you had alcohol, and then you had to choose between those 2. Which is my primary functional group? That's not the case with example 4. Both are COOH. Both are COOH. That means this is your primary functional group and this is also your primary functional group, because they are identical. So you must select a carbon chain which includes both of them. And that's quite simple. You go from this end to this end. That becomes your parent carbon chain. Let us move to the next one. Is there a functional group? Yes, sir. This is a functional group, CHO. The CHO could also be written like this, or it could be directly written CHO. Point to be noted is that this is different from COH. COH means alcohol and CHO means aldehyde. Students often get confused. COH, that order is important. COH means alcohol, COH means alcohol, and CHO or C double bond OH is aldehyde. So here I have 2 aldehyde groups. And as I have said for example 4, if you have identical functional groups, twice, you must include both of them in your PCC. But let us try to see it in context of the priority. All right. So this is my functional group, sir. Let us start with one functional group. So that means this carbon must be included in the PCC. So here I move. And at this point, I have a question, whether to turn left or to move right. That question will be answered by my priority. Is there a functional group on left side? No. Is there a functional group on right side? Yes. That means I am going to turn right over here. Sir, why did you turn right? Because turning right gave me an opportunity to select the primary functional group. Again, at this carbon, you will ask yourself a question, whether to move straight or to move down. Again, go to the priority and check. If I go straight, do I find a functional group? No, sir. If I move down, yes, that means you will move down. So that is going to be your parent carbon chain. I hope this is clear to you. Moving to the next example. All right. Again. Now see, is there a functional group present? Yes, sir, definitely. Which is that functional group? Check. It is OH. It is OH. Now OH is slightly a different type of functional group than aldehyde or carboxylic acid. Sir, how it is different? Carboxylic acids, ketones, aldehydes are such functional groups which have their own carbon. In COOH there is a carbon. These are the functional groups which contain the carbon. In which case you include the carbon of the functional group in PCC. In which case you include the carbon of functional group in the PCC. So these are those functional groups which have their own carbon. But OH is not like that. Alcohol doesn't contain a carbon of itself, but it is connected to a carbon. So this is called alpha carbon. This is called alpha carbon. A carbon connected to the functional group is called alpha carbon. In context of PCC, then we will say, since OH doesn't have a carbon of its own, we must include alpha carbon in PCC. Earlier, we were including the carbon of the functional group in the PCC, but OH doesn't have a carbon in it. So we will include alpha carbon, that carbon which is connected to OH in the PCC. So now one thing is clear to me, sir, this carbon has to be included in the PCC. Fine. So I could, in that case, come like this, or I could come this way. See here. Up till here it is a straight line. There is no branching. There is no carbon branching over there. Over here I'll ask myself a question, whether to go up or go down. You will see that whether you go up, whether you go down, it makes absolutely no difference. You can turn either way. Absolutely no problem. So that's going to be your parent carbon chain. Okay, this was quite simple one. Coming to example number 7. We check which is our functional group. We check which is our functional group, and you will find out that there is no functional group. There is no functional group, sir. Therefore, the first priority of functional group cannot be used to select the PCC. Then, since the conflict cannot be resolved over here, we move to the next step in priority, that is multiple bond. Sir, what does that say? It says that you have to select a carbon chain such that it has maximum number of multiple bond. You have to increase the number of multiple bond as much as possible. You have to increase. Okay, so I have terminal 1, so I could go from here to here, or I could go from here to here, or I could go from here to here. Let us explore the first option. If I go straight, I end up with 2 multiple bonds. If I go down, I still have two multiple bonds. If I go this way, I still have two multiple bonds. So now that's a tension. That means I cannot use even the multiple bond to resolve my conflict. So in that case, I must look for the number of carbons. In which path, on which path will I encounter maximum number of carbons? 1, 2, 3, 4, 5, 6, 7. If I go straight. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That means the number of carbons is also cannot be used for selecting the parent carbon chain. तो ये भी चला गया sir. Then I check for substituent. If I select this straight chain like this, I will have this one substituent, right? Since there is one link means one substituent. If I select this way, I still have one substituent. And if I select this way, I still have one substituent. What it means is that you can select the carbon chain either way. All three are correct. Because from this carbon, if you see, this branch, and the third, this branch are same. All three branches are same. So from this carbon, whether you take this path or this path or this path makes absolutely no difference. Therefore, we could select the PCC in any way, it will be right. So one lucky example. You cannot make mistake with this. Moving to the next one. Example number 8. Let us check. Sir, do we have a functional group? No, sir, we don't have a functional group. So I'll erase this. And yes, sir. Do we have multiple bonds? Yes. So we have to select the PCC in such a way that we include maximum number of multiple bonds. Okay. If I go straight, I have two multiple bonds. If I go down like this, I still have two multiple bonds. Again, I'm looking at multiple bonds. I'm not distinguishing at this point between a double or a triple bond. I'm treating them equally. So if I go straight, two multiple bonds. If I go down, still two multiple bonds. And if I go like this, then also two multiple bonds. That means I cannot use this criteria also to resolve the conflict, because all the paths 1, 2, 3 are giving me same number of multiple bonds. Then I shall look for number of carbons. If I go straight, 1, 2, 3, 4, 5 carbons. If I come this way, 1, 2, 3, 4, 5 carbons. Or if I come this way, 1, 2, 3, 4, 5. So over here, I could have selected the parent carbon chain this way, such that I have two multiple bonds. The number of carbons are 5. Or I could have selected the parent carbon chain this way, such that again I have two multiple bonds and 5 carbons. But this example is not like the 7th one. In 7th one, the chain across this carbon were symmetric. They were same. This part, this part, this part. But here, these two multiple bonds which you have, one of which is double, other is triple. One is double, other is double. So here, In two multiple bonds, you have two double bonds, and here you have one double bond. So this is a very, very important example. Students generally miss out on this. It says that if number of carbons are same, if number of carbons are same, the number of carbons are same, yes sir, here also 5 carbons, here also 5 carbons, and of course multiple bonds are also same, then preference is given to double bond. Preference is given to double bond. We don't distinguish between a double and a triple bond to start with. When you start with, for you, they are simply multiple bonds, whether it is double, whether it is triple bond. But when you encounter that the number of carbons are also same, it is at this point that you will say, sir, one is giving me more double bonds, other is giving me less double bond. I'll say select that carbon chain which gives you more double bonds. This guy gives you 2 double bonds, and this guy gives you only 1 double bond. That means this example, this way of selecting the PCC is wrong. This is right. This is right. Moving ahead. Yes. Sir, is there a functional group? No, sir. There is no functional group, sir. Sir, are there multiple bonds? Yes. So, I have to select a carbon chain such that I have maximum number of double or triple bonds, such that I have maximum number of multiple bonds. Some few examples back, I had explained if a particular functional group, if the identical functional group is present twice, both are to be included in PCC. Both are to be included in PCC over here. If there are two COOH, both are to be included in PCC. If there are two aldehydes, both are to be included in PCC. Likewise, if there are precisely two double bonds, both are to be included in PCC. But let us try to see it in context of priority. Sir, functional groups are not there, multiple bonds? Yes, sir. Let us start with one multiple bond. I will select this multiple bond. Over here, I ask myself a question. If I turn right, if I turn left, I get no double bond. If I turn right, there is a double bond. Therefore, I will not turn left, I'll go right. Over here, I'll again ask myself a question. If I go straight, do I get a multiple bond? No. If I go down, yes. Therefore, I shall go down. This is the way. Now, if you see, there are only 4 carbons. If you had to go straight, you would have got 6 carbons. Then why are we selecting the shorter carbon chain? We are selecting the shorter carbon chain because number of carbons gets lower priority than number of multiple bonds. We have to prioritize more multiple bonds over more number of carbons. For example, over here. Now, it has become very obvious to you. Sir, there is no functional group. Therefore, I must include as many double or triple bonds as possible. Now, how can that be done? Now, you already know, like this. But if you simply look at the number of carbons, see here. 1, 2, 3, 4, 5, 6, 7, 8, 9. But if I had to go like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let us say that at this point, I ask myself a question, whether to turn right or whether to turn left. If I come in like this, right or left. Sir, if I turn left, there is no multiple bond. If I turn right, there is a multiple bond. Therefore, you will turn right over here. So this is going to be our parent carbon chain. I'll move ahead. Now we have come to the simpler organic compounds. Okay, I started with the functional groups and now we have moved to simple alkane chains. There is no functional group, there are no multiple bonds, so I can strike out the first two priorities. These examples you will see there are no functional group, there are no multiple bonds. So my motive is to select as many carbons as possible. And how can that be done? I'll give you one trick. Okay, I'll give you one trick. For alkane chains, let us say that there is a carbon here. There is a carbon here. Okay. Here there is one branching, there is one carbon. Here there is a branching, there are two carbons. Now at this point when you arrive from wherever that you are coming, you will ask yourself whether to take left or to take right. You have to go from this point of intersection, you will choose that path which is longer because there will be more carbons. So instead of going up, you will go down. Alright. Now let us say that from this point, I have three places to go, three roads going over here. So from this path, from this point, I will select the longest carbon chain, sir, 3 carbons. And then from here, whether to go up or down, well, I will go down. So from any point of intersection, you will choose 2 longest roads, the highest and the second highest. For example, over here, if I go left, 1, 2, 3, 4. If I go here, 1, 2, 3, 4. If I go here, 1, 2, 3, 4. This is that example with double bonds. You cannot be wrong in such cases. You cannot be wrong in such cases because here also 4, here also 4, here also 4. So no matter from where you go where, you will end up with the correct answer. But now, if I increase the number of carbons over here, then you will say, sir, the highest number of carbons from this particular point of intersection is this chain. 1, 2, 3, 4, 5. So therefore, I must select this carbon chain. At this point, you ask yourself a question, which is the longer path? 1, 2, 3, 4. 1, 2, 3, 4. So you can take any one. But now which one will you take? Sir, 1, 2, 3, 1, 2, 3, 4. So you will go like this way. This logic you will apply for simple alkane chains and you will easily end up with the longest carbon chain. Over here you see, there is one point of intersection over here. So should I go up or should I go down? Should I go here or should I go here? It doesn't make any difference. It doesn't make difference because top also you have one carbon, here also you have one carbon, तो कुछ फर्क ही नहीं पड़ रहा है. Alright. Likewise from this point, should I go up or down? Obviously should go down because down there are 2 carbons. Here there is only 1 carbon, you will not go here. Alright. And from this point, where will you go, sir? Sir, here this is the longest carbon chain. So my longest carbon chain will look like this. Like this. Let me elaborate again with example 12. Let me take step by step. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. At this point of intersection, it doesn't make any sense for me to check whether I should go up or down. You can come either way, absolutely no issue. At this carbon, you have, let us say 1, 2, 3. Should you go straight or down? You will go down. Because down there are 3 carbons, straight there are only 2 carbons. At this point, if you go straight, you have 2 carbons. If you come down, you have 3 carbons, so you will come down. So this is the best way of selecting the longest carbon chain. Over here, let us try to select the longest carbon chain. So from this point, if I go up, I encounter 2 carbons. If I go down, I encounter 2 carbons in a chain. Of course, there are branching. Okay, fine. Likewise, from here, if I go straight, I encounter 2 carbons. If I go straight, also I encounter 2 carbons. So which one to check? Which way to take? We will take that way. आ जाओ भाई. Okay. If the number of carbons are same, check for the number of substituents. If the number of carbons are same, check for the number of substituents. If I go straight, तो मान के चलते हैं, then I will have 1, 2, 3, 4, 5, 6, 7, 8 carbons, and 1 substituent hanging from here, 1 substituent hanging from here. So total 2 substituents. If I go that way. Okay. However, if I select this path, check 1, 2, 3, 4, 5, 6, 7, 8. This way, then I have 8 carbons plus how many substituents? Sir, here there is one, here there is one, here there is one, here there is one, over here. So 1, 2, 3, 4, 5 and 6 substituents are there. Therefore, I will select this parent carbon chain. Let me rewrite this. So the parent carbon chain would be 1, 2, 3, 4, 5, 6, 7 and 8. And which are my substituents? This is my substituent 1. This is the second substituent 2, 3, 4, 5 and 6. So total 6 substituents and 8 carbons. All right, so let us move to the 14th example. In this, check if there is a functional group. Yes, sir, there is a functional group over here. But sir, there is one more functional group here, aldehyde. But then who is our primary functional group? Sir, this is our primary functional group. And in that case, this guy becomes our substituent. That means we have to select a carbon chain such that this particular carbon is included in the parent carbon chain. At this point, I ask myself a question, whether to go straight or down. The answer depends on whether there is a functional group here or here. Sir, there is no functional group here. Here also there is no functional group. But sir, there is a functional group. No, Baba, this is substituent already. I told you, once you have decided who is your primary functional group, the other functional group becomes your substituent. So that means there is no functional group here, there are no functional groups over here. Check for multiple bonds. Sir, is there any carbon-carbon multiple bond here? No. Sir, is there any carbon-carbon multiple bond here? No. Sir, but there is one. That is a carbon-oxygen. We are speaking about carbon-carbon double bonds or triple bonds. Since no functional group, since no multiple bonds, we will move to the next criteria, that is number of carbons. If I go straight, I will encounter 2 carbons. If I go down, I may get 1, 2 or 1, 2. So whether you go straight, whether you go down, the number of carbons will be same. However, if you come down, then the number of substituents will be more. If you had to go straight, you would have only this one big substituent. But now that you have moved down, you have, see, 1, 2, and this oxo, 3 substituents. Let me again do that for you. Sir, once I move down, if I go left, I have 1 carbon. If I go right, then also I have 1 carbon. So where should I turn? See, if you turn right, if you had to turn right, you would have 1 plus 1, 2 substituents. But if you turn left, then you would have 1, this is ethyl substituent, 2, this methyl substituent, and this double bond O, which is called oxo substituent, So total 3 substituent. This is therefore the correct way of selecting PCC. I'll make one small modification to this and make another example. Again, please pay attention. Here we have a primary functional group. So that means this carbon has to be included. So over here. Then I'll move down. You know now already why. Now pay attention here. If I turn left, I encounter 2 carbons. If I turn right, I encounter only 1 carbon. In which case, I will turn left. So here, if you had to turn left or right, you would end up with only 1 carbon. That's why you had to move to the next priority, which is number of substituents. But here that's not the case. Here if you turn left, you have 2 carbons. If you turn right, you have 1 carbon. So we'll definitely choose 2 carbons. By the way, this CHO is an aldehyde functional group. It has 2 prefixes. If aldehyde carbon is included in PCC, in this case, then the substituent name, this oxygen hanging out, is called oxo. When aldehyde's carbon is in the PCC, this oxygen hanging out is called oxo. But when entire CHO is a substituent, in this case, then the prefix for this becomes formyl. The name of this substituent becomes formyl. The name of this substituent we already know is ethyl. This one is methyl. This one is again ethyl. So when aldehyde functional group is there as a substituent present, then be careful. If the carbon is inside PCC, the substituent's name would become oxo. If the entire CHO is outside as a substituent, then the name would become, the prefix would become formyl. Let us take up one last example. Here also I have 2 functional groups. One is COOH and other is nitrile or cyanide. This is my primary functional group. Immediately this guy becomes substituent. So I'll go straight like this. If I go straight, I have 1 carbon. If I go down also, I have 1 carbon. But the point to be noted is cyanide is either your primary functional group, which in this case it is not. Cyanide is either your primary functional group or it is substituent, fully outside PCC. It is not like aldehyde. Aldehyde may be inside PCC, may be outside PCC. But cyanide is not like that. Cyanide is either your primary functional group, in which case its carbon will be in the PCC. But if cyanide is not your functional group, like in this case it is a substituent, then it is never included inside PCC. Is cyanide your primary functional group? No sir, that means it should be left outside the PCC. So this becomes your basis. So in today's class, we learned how to select a parent carbon chain. I adopted a slightly non-conventional way of teaching. We generally start with simple alkanes and then move to the compounds having functional groups. However, I started with the compounds having a functional group and then moved to the simpler ones. I hope you liked this video. Thank you so much.